Hello. In today's video, we are going to talk about linked lists. What is a linked list? At its core, a linked list is a data structure that consists of a sequence of elements, each connected to the next one by a link or a reference. These elements are called nodes. Linked lists come in various flavors, such as singly linked lists, where each node is connected to the next one, doubly linked lists, where the node has a reference to the next and the previous node, allowing for more efficient navigation in both directions, and lastly, circular linked lists, where the last node in the list has a reference to the first node on the list, making it circular. In this video, we will concentrate only on the singly linked lists. In a singly linked list, each node contains two fields, a data element and the reference to the next node in the sequence. The last node typically points to a null reference, indicating the end of the list. So let's start the IDE and let's build a linked list in Go that holds some integers. So the first thing to do, we need to go and declare a module in Golang. To do that, we need to go to our console screen and then type go mod init, and let's call it linked lists. We have just created a module called linked list, and now we should be able to start writing our application. So now on our IDE, we need to create a file main, which will, and the package has to be main also, main, because this is the entry point for our application. And let's define an empty function called main, main. And now we can start defining our linked list. So let's start with the node. So node is going to be a struct. And the data, it will be int. So it will hold the integers. And next will be a pointer to a node. So this is basically pointing to the next element or next node in the linked list. Now let's define the linked list. Linked list is also a struct, and linked list has only one element, and that is the head, and it's going to be a pointer to a node. This is how we define a linked list. So it's actually quite simple. So if we want to use our linked list, we can create a linked list. So let's call it list, and then we can say linked list, and head is going to point to nil. So this linked list is actually an empty list. To add elements to this list, we can go and define a node first. Node, but the node has to be a pointer or a reference to a node. So let's call this node 1, and data, let's put a value of 10 in here at the moment, and then the next element or the pointer to next element is going to be nil, because without pointing to anything. And now on our list, we can specify the head to point to node 1. So now, let's add a few more nodes in here. So let's define node 2. Again, is going to be a reference or a pointer to a node. And then data is going to be, let's say, 5. Next is going to be nil. So now we need to add or to basically link node 1 with a node 2. So we can go say node 1 dot next, is node 2. And then let's define another node, node 3, which is again a pointer to a node. And then the data, let's 3 in there. And next is going to be nil. Now we need to say node 2. So we need to link node 2 with a node 3. So next is going to be node 3. Sorry, node 3. Okay, this is quite a tedious way of adding elements to the node. So instead, let's actually create a receiver function on the linked list that will append data to this linked list. So let's define a function called append that is func, and the receiver is a linked list. And we are defining it as a pointer because we want to change this instance. So if we do append, and let's do data, which is going to be an int. And in here, we need to create first a new node, and then is going to be a pointer to a node. And this is literally going to be data is with the data. Next is going to be nil. So there are two scenarios in here. First, we can append a node when on an empty linked list. In this scenario, we first need to check if the head is nil. So if linked list.head is nil, that means the list is empty. So the head will point to the new node. So l.head is going to be new node. And then we return. Otherwise, we need to traverse the linked list from the head until we find the last element, and then on the last element we need to add the node. So we actually need to link the node with the last element. So let's do this. So let's do current node is the head, and then let's do for current node dot next is not nil. So basically we're saying while current node points to something, we are updating current node with current node dot next. And then we are saying current node dot next equals with a new node. Right. So again, what have we done here? So now it's going to be much easier to append elements to the node, to the list rather. So now we can delete all of this stuff, and then we can literally just say list.append. So let's append element 10. Then we can do list append element 2, list append element 5, 7, 4, and so on. So now we literally have a list with 5 elements. To traverse the list, first we create a node, or define rather a node, current, which points to the head of the list. So list.head. And then we do for current is not nil. We want to print the node's data. So let's do this current dot data, and we need to say current equals current dot next. So we are traversing from one node to the next, to the next, to the next. So let's run this application. So if we go run main.go, and as you can see, we have the elements 10, 2, 5, 7, 4. Let's add another receiver function on our list, and this time the function will print all the elements of the list. So func linked list, and let's call the function print, and then let's traverse the list. So we define a node that is going to point to the head of the list, and then we traverse the list. So for current is not nil. Now we say format printf. So let's do the number or the value of the node, and then a pointer which points to the next element. So this is going to be current dot data, and then we make current dot next. So basically we moving from one element to another. And now if we run the application, so let's get rid of these statements, and let's call list.print, and then let's run the application. So, and now you can see we got 10 that points to 2, 2 points to 5, 5 points to 7, and 7 points to 4, and 4 points to nothing. To make this better, we can, at the end, we can actually, let's do this, and then in here we can do format println nil. So let's run again this code, and it's much better. So 10 points to 2, 2 points to 5, 5 points to 7, 7 points to 4, and 4 points to nil, which is exactly our list. For almost all the actions that we take on the list, we actually need to traverse the list. So let's say we want to find a specific node in the list. To find a specific node, we need to go to head first, and then we need to traverse the list until we find the specific element. So let's implement a get function on the list that will return a specific node that contains the data that we ask. So let's call this function, again, is going to be a receiver on linked list, and let's call get, and then let's pass the data that we are interested, data that the node holds, and this will return a node and a boolean value specifying whether it found the node or not. So we need, as we said, we need to traverse the list. So let's create or define a node current which points to the head of the list, and we can say now we need to traverse the list. So while current is not nil, we need to do if, so we need to check if current has the data that we are interested, and if it found the data, we return current, and true, that means we have found the node. Otherwise, we need to say current equals current.next. So basically, current becomes the next element. And if we traversed the whole list and we didn't find the data, we return a nil value and false. So now let's see if we can find the node that holds number 7. So let's do list.get and the value of 7, and this is going to be node, and this is going to be okay or found. So if found is true, then we say print ln found the node data is, let's say, node.data. Otherwise, list does not contain a node with the data, or with number 7. Let's run the application. and found the node data is 7. Number 7. So now we have a list with 5 elements that looks something like. So if we want to delete, let's say for example we want to delete node 5, what we do is literally from node 2 we remove the pointer to node 5 and we update the pointer so it points to node 7, and then we sever the link from the node 5 to node 7, and then garbage collector will literally collect the node 5. So what we left with is this. And now if we update the link, we should have a list that looks like this. So as you can see, we didn't need to shift or move any of the nodes on the list. We literally just updated the references. So let's implement delete function on our linked list. So let's go and define the function delete. So func receiver is going to be the linked list. Delete. We are going to provide the data which will find the node that will be deleted. When we delete a node from the linked list, we need to keep in mind that the list might be empty. So we can't delete from a linked list. So let's test for that scenario. So if l.head equals nil, that means the linked list is empty. We just return. The next scenario is when we are deleting the head. So let's test for that scenario also. So if l.head.data equals with data, that means this is the node that we want to delete. Then we just say l.head equals l.head.next and then return. And the next scenario is when we want to delete a node which is somewhere in between two different nodes. So to do that, we have to traverse the list, find the node, and then delete the node, or rather adjust the references or pointers from one node to the other. So let's do that. So we start with the current. Current node is going to point to our head. Then for current.next is not nil. So if current node points to a valid node, so it's not the last node, then we are checking if current node.next, so the next node is the next node, the node that we want to delete. And if yes, current.next equals to current.next.next and then return. Otherwise, we need to move current to the new node. So we say current.next. And this is our delete function. So what is happening to this block of code? So let's create a list as an example, and then we can explain the code as it happens. So let's say head, we have a list that head points to node 10, node 10 points to node 2, node 2 points to node 4, and node 4 is the last element on the list. So now, if we want to delete node 2, we start from the head. So we say current is our head. So in this instance, current is node 10. Now we're saying, does node 10 have a valid node that points to, so the next node that it points to. In our case, yes. So now we're saying, okay, if current.next.data is the same data that we provided, which in our case it is, so because current is head, so the next node, the data on the next node is number 2, which is the one that we want to delete. Now we're saying current.next, so current.next is going to be current.next.next. So because current is our head, current.next is number 2, and current.next.next is number 4. So therefore we're saying the next node that node 10 is pointing to is going to point to number 4. And we are deleting that link. And this is basically how we delete a node from the linked list. Inserting elements in a linked list is also very efficient because we're not shifting or moving elements. So instead, we just create a node and we adjust the references to the nodes. Very similar to when we deleted the node. So let's implement a function called insert after on our list. So func, our receiver is again the linked list, and let's do insert after. The function insert after takes 2 arguments. The first argument is the node, or a pointer to the node, and then data is int. So basically we are going to add a new node after this node. So the first thing that we need to test is to check if the node provided is nil. So if node is nil, we basically can return an error. Cannot insert node is empty. And we return. Otherwise, we create a new node, a pointer to a node rather, and we say the data is the data that we passed. And now new node will point to the node that we provided, and then node.next is going to be new node. To explain what is happening in the insert function, let's create a list. So head is pointing to, let's say, node 5. Node 5 points to node 11. Node 11 points to node 15. And node 15 is the last element or node in our list. So let's say we want to insert a new node after node 11. Okay, so our node that we're passing is going to be node 11. And now in here we are creating a new node. And then let's say the data for that node is going to be 7. Now the new node will point to where our provided node pointed to. So in our case, node 7 is going to point to node 15, and then our provided node is going to point to a new node. And we are removing this connection. So as you can see, now node 11 points to node 7, and node 7 points to node 15. As we can see from the examples in our code, linked lists offer several advantages. One of them is efficient insertion and deletions. That means we can easily add or remove nodes without reorganizing the elements in the list. Linked lists have a dynamic size, which means as we add more nodes or remove them, The linked list automatically adjusts its size, making it very memory efficient. So this concludes our video about linked lists. Thank you.